So this is called the picture activity, and this is a review or summary of the ideas of linear equations, so graphing lines and writing equations to fit those lines. This encompasses all the concepts of parallel lines, perpendicular lines, horizontal lines, vertical lines, slope-intercept form, y-intercepts, and x-intercepts. So all of that is in this one activity. So the goal of this activity is to draw a picture using only connected straight line segments on a graph. The goal is to label each line with its equation in slope-intercept form. So in the form y equals mx plus c, otherwise known as y equals mx plus b. Some requirements that I set for this activity is that you must have at least 20 unique equations or line segments in the drawing. In the drawing, there should be at least 2 pairs of parallel lines and at least 2 pairs of perpendicular lines. You should have an equal mix of horizontal, vertical, and diagonal lines with varying slopes and y-intercepts. And a suggestion is if you use symmetry about the axis, whether the x-axis or y-axis, it does make writing the equations and writing the slopes and y-intercepts a bit easier. So I want to explain some parts of this and how to best make this. First off, notice I just used square paper and I drew an x-axis and a y-axis by splitting the page down the middle on both sides. This allows me to create a bigger drawing and to label the axes however I choose. So I've chosen to make my x-axis go from -18 to 18 and my y-axis go from -27 to 27. Each unit is one unit represented with the grid. So a couple things I want to point out. You can see some of the parallel lines, perpendicular lines in my drawing. For example, these 2 lines that are the outline of the cat's face are parallel lines, whereas the bow, the ear of the cat, and the side of the bow are perpendicular lines. And you can see that by the slopes. You have a slope of 1/2 for the bow line, but a slope of -2 for the ear. So -2 and 1/2 are opposite signs and reciprocals, so that's how you know that those lines are perpendicular. You'll also notice that the other side of the bow and the other line are also perpendicular lines. And you'll notice things like, because of symmetry, the sides of the cat's eyes are parallel lines. They're both -2x for the slopes. So those lines are parallel, and also these sides of the lines are parallel, and things such as that. So you'll notice that there are parallel lines throughout here, but there's also some perpendicular lines. You may notice that the nose of the cat, these 2 lines connect, and these are perpendicular lines. You have a slope of 1 and a slope of -1, so you also have perpendicular lines there. So I have met the requirement, and I actually have more than 2 pairs of parallel lines and 2 pairs of perpendicular, so it's actually pretty easy to come up with that. You'll also notice that I have a variety of the types of lines. So I have parallel lines, I have perpendicular lines, but I also have a mix of these vertical lines that make up parts of the cat, such as the nose and the sides of the face. I also have horizontal lines, like the top of the cat's head, or the bow, or the nose of the cat. So I have a mix of horizontal and vertical lines, but I also have diagonal lines. So all of these other lines that aren't horizontal or vertical, these are my diagonal lines. So I have a good mix of all types of lines. You'll notice that all of the vertical lines are x equals lines because they cross through the x-axis. You'll notice that all of the horizontal lines are y equal lines because they cross through the y-axis. Their slope is 0, where the vertical lines, their slope is undefined. Probably the hardest part of drawing this picture with line segments is knowing the y-intercepts. The slopes are pretty simple. You just pick 2 points on a line and you count the rise over the run between those 2 points. So for example, if I look at the mouth of the cat, to go from the start of the mouth of the line segment to this end of the line segment, I would count the rise and the run. So the rise is 2 units, and then the run is 1, 2, 3 units to the right. So a rise of 2, a run of 3 means I have a slope of 2/3 for that part of the line. You can do that with the rest. It's pretty self-explanatory, but slope is rise over run. So when you're wanting to find the slope of any of the lines that you've drawn, pick 2 points that are on that line and count the rise and the run between those 2 points to get your slope. Always write your slope in simplest form. So if the slope is 5/10, simplify it to 1/2. For the y-intercepts, that's a little bit harder. One way that you could do this is to use a straight edge or a ruler and extend the line segment to see where it would cross in the x or y axis, which in this case I want to know the y-intercept, so I want to know when does it cross the y axis. So for example, with the ear, notice that the line segment ends here, so I don't really know where it crosses this y axis. But if I use the ruler and I extend this line, and I need to follow it very carefully, it will cross through the y-axis at 10. So that's why I know that the y-intercept needs to be plus 10 for this equation. So that's one way to do it, is just to use your ruler and extend it to find where it crosses the y-axis. And notice, because of symmetry, it makes it easy for me to know that these two lines, because they're symmetric about the y-axis, they have the exact same y-intercept because they will cross the y-axis at the same point. That's not always the case. It's only if you have symmetry that that might happen. For other lines, for example, this line, notice my y-intercept is 38, but my y-axis only extends to 27. So if I were to try to extend this, it would go off the page and I wouldn't be able to know up here where it crosses the y-axis. So this is where your knowledge of equations and of line segments and of substitution comes into play. So what I did to find this y-intercept of 38 is I chose a point on the line. So for example, let's say, let's use the tip of the ear. So we're looking at this line right here, and I'm going to use the tip of the ear, which the tip of the ear is at the point -7, 24. So x is -7 and y is 24. Let me just double check that, -7, 24. So that is a point that is on this line. I know that the slope is 2 because I already counted the rise and the run between 2 points on the line. So I'm going to write y equals 2x. Right now I don't know the y-intercept. That's something that I needed to find, so I'm just going to put plus c, or if you use plus b to represent the y-intercept. Now I'm going to use substitution. I'm going to substitute my point that is on the line into the equation to solve for c, which is the y-intercept. So in place of x, I'm going to put -7. In place of y, I'm going to put 24, and in place of c, I'm just going to leave it as plus c. Now I need to solve the equation for c. So I'm going to simplify -2, or 2 times -7 is -14. I'm going to move the -14 to the left-hand side by adding it, the inverse operation, and I get 38 equals c. So that's how I found the y-intercept of that equation is 38. It would cross the y-axis at 38. So this is another method you could use to find the y-intercepts of your line segments. If the ruler doesn't work, or if you don't trust the accuracy of lining up the ruler and checking, you can use substitution with a point and the slope of the line to find the y-intercept. So again, this is called the picture activity. This is a fun activity you can do to help you review through all the things about linear equations.